morning everyone. Today I'll be covering a very important topic of organic chemistry, which is nucleophilic addition reactions, along with examples of some important reagents like Grignard reagent in the formation of cyanohydrin, acetal, hemiacetal, and then the mechanism of every reagent. So what actually are addition reactions? In an addition reactions, a nucleophile and electrophile is involved. Nucleophile attacks the electrophile, the weakest bond breaks, and we get our product. So a nucleophile is an electron-rich species, whereas an electrophile is an electron-deficient species. So naturally, a nucleophile will attack the electrophile, weakest bond breaks. Simple procedure, we'll be following it multiple times throughout the presentation. So here, this is the nucleophile. This carbon atom right here, this is an electrophile. How is it? This oxygen present here is an electronegative atom. So it will pull the electrons in this bond towards itself. This will create a delta negative charge here and a delta positive charge here. So the carbon becomes electron deficient. Now this nucleophile will attack this carbon and this bond will be formed. This bond will break because it is a pi bond, it is the weakest bond present here. This H plus present in the medium, it will attach with the O minus that is produced there. This is the basic procedure. Now, let me teach you this with proper details. So, carbonyl systems are planar systems. Carbon is sp2 hybridized, so it is present on a plane. So, nucleophile has two options, to attack from the top and to attack from the bottom. Here, it can choose any pathway which is comfortable. The nucleophile attack the carbon atom. You can see the delta positive charge is present. Nucleophile attacks this bond right here. This will break and oxygen will get a negative charge. You can see the same thing happens here. This will be a slow step because bond breaking and all requires energy. It consumes a lot of time basically. And this reaction, when H plus is added to the oxygen, it takes place quickly because it's a basic electrostatic attraction. Now let us understand this with the help of an example. This is hydrogen cyanide acetone. It is giving a cyanohydrin. Now what actually happens in this? Now, as we have discussed earlier, this carbon has a delta positive charge because of the oxygen present there. So this negative charge will attack this position. The weakest bond breaks. So the weakest bond is the pi bond. This will break. And this is formed. Now you can see this H plus is unused. This H plus will attach over here, this minus charge, and it will form OH. So this is a cyanohydrin. This is what is formed actually. Simple procedure, nucleophile attacks the electrophile, weakest bond breaks. This is what is basically happening in all addition reactions on over here. Now Grignard reagent, a very important reagent because this is a type of reagent where actually carbon acts as a nucleophile, which is very rare to see. So this is only because magnesium is an electropositive atom. it will not form covalent bonds, it will try to form ionic bonds. So what happens? R minus Mgx plus is the bond that exists here actually. You can see here how Grignard reagent works. Again the same procedure, the nucleophile will attack electrophile, weakest bond breaks, and then we get our product. Here R minus will be the nucleophile. Here, this R minus has, this R group has a negative charge, so this will attack this carbon over here. The weakest bond will break, this is the pi bond, usual procedure. And now, Mgx plus is actually present in the medium. So here Mgx plus will be added due to electrostatic attraction. Now by adding some water, this Mgx leaves and H attaches with oxygen. This is how a Grignard reagent works. So now, if anyone has any questions, you can ask.
Why does alkyl group of the Grignard reagent attach with the carbon of the carbonyl group?
As I've explained right now, magnesium is it's a very electropositive element. So it is a group 2 element. So you know it will be a very alkaline earth metal. It is a electropositive element. So Mg does not form covalent bonds at all. It will only prefer forming ionic bonds. So Mgx present. The ionic bond will be like this. R minus will attach with Mgx like this. It won't be an ionic bond. It will simply be ionic bond. So what happens is this R minus can be removed when it is added in water. So R minus and Mgx will be present in the solution. So this R minus will actually attack that carbon atom which is electron deficient, and we'll get the bond formation. Any other question?
You have explained the formation of cyanohydrin. Are there any other examples of nucleophilic addition reactions with carbonyl compounds?
There is one, a very important reaction. It is acetal formation, hemiacetal formation. So what happens here is, here alcohol is present. Now this oxygen has lone pairs on it. This will attack this carbon atom. This oxygen atom present right here. It will act as a nucleophile, attack this carbon atom, and then this bond will break. This is what we get. This is an acetal. The final product that we get, that is an acetal. Any other questions?
Out of aldehydes and ketones, which is more nucleophilic and why?
Among aldehydes and ketones, you can see aldehyde, it is CHO. here on one side we can have R, we can have, and on the direct carbon atom, H is attached, which means it has less hindrance present. In case for ketone, there is RCOR. I'll show this with a diagram. Here you can see hydrogen atom. It is not a bulky group. It's just one single atom present here. So attack over here will be much easier. On the other hand, for ketone, two bulky alkyl groups are present. A bit difficulty for the nucleophile to attack was there will be hindrance present. So aldehyde will be more in general reactive than ketones. Any other question?
Why is the second step of nucleophilic addition reaction faster than the first one?
The first step involves nucleophile attacking the electrophile. Now here bond breaking is taking place. This is not a simple process. We need to supply some energy. This takes a lot of time. You know, the bond breaking sometimes requires thousands of kilojoules of energy. So this will take a lot of time to happen. You know, nucleophile has to reach the compound and then bond breaking takes place. It's all a lengthy process. Second step, on the other hand, H plus is present in the medium itself. This is basic electrostatic attraction. Negative attracts positive, positive attracts negative. So this will immediately attach here and we'll get OH over here. Any other questions? Okay, that's it for my presentation. Thank you everyone.